So thanks for attending. We're going to have a little bit of a different presentation than I think most of you have seen in the other ones. You won't see any code in this one. It's really about our experience, the three of us as a team, in building out an internal ecosystem of Python tools and packages that serve to scale and make our data scientists more efficient in their work. So in doing so, I'm going to kind of kick this off, give you a little bit of introduction of who we are, who the company that we work for is, and kind of introduce the ecosystem we've developed over the last, let's see, oh, sorry, I was just trying to see if the video thing worked, over the last 2 years. And then I'm going to hand it off to Ethan and Gus, and they're really going to talk about probably the more important things in this presentation, and that's like the key themes that we have found that have made this ecosystem successful. All right, so who are we? So we got some short introductions earlier on by Marcelo. Thank you again. So my name is Brad. We got Ethan and Gus here, and we all work for the same company, 8451. And actually, we all work for the same team within the company, and we sit on a specialized team within the company that basically serves to build internal tools for a data scientist. And when I say internal tools, I would say 95% of that are Python packages. So we are all data scientists, but we are really wearing software engineering hats and building tools for other data scientists. So who's this company we work for? You likely have not heard of 8451, even if you do live in the States, but you may have heard of Kroger. Kroger is the largest supermarket retailer. Would I say supermarket? Think grocery store chains within the US. And they are the third largest retailer in the US behind Amazon and Walmart. And they own 8451. And 8451 is a company that focuses on doing data science for Kroger, and then also for all the companies that supply products to Kroger. So you think Coca-Cola, Frito-Lay, all those products that get sold in Kroger. And we do a lot of the data science for marketing and product placement within Kroger. All right, so the company has actually grown quite a bit over the last few years. We have over 250 data scientists. So likely wherever you work, that's probably a pretty large amount of data scientists for a single company. That is rare. And the way that we work is we are highly matrix, which just means we have data scientists embedded on teams alongside engineers, some R&D folks, business consultants, project managers, and so on. And that's worked fantastic. But with any growing company, we've experienced some pains as we've added more data scientists, more data science projects. We've added more compute environments. We do operate in Azure, GCP, and we also have on-prem Hadoop. And so with that, what we have experienced is a lot of duplication in code, and also code inconsistencies, and just some common procedures, common code procedures that we do throughout the company. And this is really what kind of forced our team to kind of come into existence. And we spent the last 3 years building out an ecosystem of internal packages, Python packages, that serve to simplify and make a lot of these code procedures common across the different teams, and also to scale the work. So you can see we have a lot of packages that are focused on providing ease and data access, to be able to do basic data wrangling, aggregation, some modeling tasks, managing our environments, and then also some developer tools. And so just as a real quick example, like how do these data scientists use these packages? Well, for a given problem, for example, if a data scientist needs to compute some key performance metrics for a certain product sold in certain Kroger stores across the US, they could actually take these different Lego pieces or different internal Python packages to do parts of this task, right? So it could be setting up their Spark configuration in a efficient manner. They could be using another package to work with the different types of Kroger fiscal dates that we have. They may use another package to be able to identify wrangle and extract UPC information about a certain product and so on. So the idea is that we have all these different packages that serve different parts of that data science workflow. And the data scientists can just kind of plug and play with these Python packages to simplify their procedures. All right, so the benefits that we've seen, I'm not going to read all these bullets, but really it comes down to faster innovation, faster data science development. It allows them to scale their work much quicker, and better governance. So we have data scientists that are performing common procedures in a similar manner. And we can pretty much guarantee when they use these packages that they are doing it in a way that's become accepted as a best practice within the company. All right, so what have we seen with this ecosystem? Well, just to give you an idea, we are well over 25,000 function calls per month. And we typically have over 100 distinct data scientist users from within the company using these packages each month. So that's kind of an idea behind like the ecosystem we've created. But really what we want to talk about for the rest of this presentation is what are some of the key themes that we have found as we develop this ecosystem that have made it successful. And that's kind of where Ethan and Gus are going to jump in. So Ethan?
Yeah, thanks, Brad. So we're going to move through a lot of these slides pretty fast. There's a fair amount of content, but I actually sent a link to the presentation to the chat. So if anybody wants to come back and look at some of these slides more, you're more than welcome to. Just a heads up as we go fast because we have a lot. So how do you begin to identify what sorts of things you should be building tooling around? Because we're saying that there's a lot of cases where you want the standardization or you want simplicity, but how do you identify the places where you can actually help the company, basically? So our recommendation is really to look for tasks that are specific to your company or your team, or maybe even your industry. That usually means that either there's a lot of business logic involved, or there's something about the systems you use that is complex for some reason, maybe authentication, configuration. But we would warn you not to go for things that are common problems across data science. If a problem is common across all of data science, like a modeling pipeline, for example, those things are probably either solved in common libraries like scikit-learn and pandas, or they're very difficult. That would be why there isn't some kind of tool that already exists for them. So be cautious about that. Mostly you're looking for things that are about your company or your industry. Do you want to take us to the next one, Brad? Thanks. So some examples that we've seen are things like internal sets of rules that you apply to data sets before you analyze them. So you can allow users to customize to some degree if you want, toggle things on or off, but basically apply what you might call like golden rules for best practice. Industry standard metrics. So maybe like median units sold per household, but excluding returns. That's the kind of thing that a retailer might calculate. Things like that are standard in your company, but users have to write the code for every time often. Internal systems that require configuration or authentication. I mentioned that before. We use that for things like Spark, Apache Spark, and some of our databases. And then also, if your company has a fiscal calendar that they use often and analyses work over that fiscal calendar, it's good to provide a translation layer for users to be able to go to and from that calendar from the traditional Gregorian calendar. Okay, next one, Brad. Thanks. So if you're working on this, how do you think about the problem of actually developing a tool? And not exactly from the code perspective, but just generally, like, what should your mindset be? So there's really two. There's scope, build, release, we call it, and prototype and evolve. And these are two very different things. You want to take us to the next one? So in scope, build, release, basically you're concentrating on getting the problem right and solving it correctly the first time. And that usually means gathering a lot of info to begin. And that means basically a lot of planning and something more like a product management mindset, where you're going to gather information, figure out the right thing to build, work through it, and then release it to users. And that's in contrast with the other one, prototype and evolve. And in that case, actually, this is a little more of like a hacker mindset, where you quickly tackle problems that you see. You're willing to pivot and maybe not end up solving the problem you started on based on what's doable instead of what is like high value, for example. A big focus on the problems you can solve and regularly redesign what the product is. And that usually comes down to something like interface. So we actually like that second one. So if you take us to the next slide, Brad, thanks. You find out whether the thing you're working on is buildable much earlier, which is really nice, because often we have found that if you get lost in the sort of product management mindset in tools like this, you don't get things out to your users fast enough, and you're not able to pivot based on whether something is doable and whether it's actually useful. And also, you should think about internal infrastructure as sort of like lottery tickets, where some will only be used by a few people, but some will be used by very many. And by producing more things, you have a much better chance of hitting on those lottery tickets. Next slide, please. So some advice about using this prototype and evolve mindset. Try to avoid getting lost in value quantification. That can take a long time. It does perhaps make sense with external clients, but when you're building infrastructure for your own company, often that's very slow and prone to scope creep, getting distracted. Instead, follow simpler heuristics around like, what do people find frustrating at work? Just to solve the things people find annoying. That usually leads you in the right direction. Be willing to work fast and pivot fast, throw together prototypes and throw them away sometimes, and be willing to change what you're working on. If you realize along the way that you have another problem that might be easy to solve, produce a tool for that and publish that, and feel free to not go in the original direction. And also don't try to integrate a bunch of different teams' needs into a single tool. Sometimes that works, but often it's actually more trouble than it's worth, and you don't end up producing something useful to anyone in your attempt to make something useful for everyone. Next section, please. So when you actually dig into the code, how should you think about where to spend your time and what sorts of work should be done there? Basically, our advice here boils down to focus more on the interface than the implementation. This is a hacker mindset, like we said. It's about throwing things together. And it really doesn't matter if they're fast, if they're performant, if they're built in the optimal way under the hood. What matters is if they're usable. They need to solve the problem and be usable. And that's really all you need at the beginning. You can come back and work on the underlying implementation later. But you often don't get a chance to redesign your interface because users become attached to it. Even if it's not officially anything past a beta, users just get attached to things and they're hard to change. So if you take us to the next slide, what we recommend is working on the initial implementation and interface together, and then do some iterating on the interface alone. Toy around with it, maybe in a Jupyter notebook, play around with the API you've designed, decide if it's useful, maybe redesign it, do that a few times before you make your first release. But there's no need to do that on your implementation is the point we're making here. It's about the interface that you need to get right. Okay, next slide, please. So some other advice about interface design. Interfaces matter a lot. So a coherent lead is really useful. Having one person who really sets the tone for what the interface is like makes it feel more cohesive and makes people catch on to it faster. Be careful about naming. It's very easy just to be sloppy about names and not pay attention to things that like functions that aren't present tense verbs and things like that. But that'll come back to bite you later when you can't break backwards compatibility. Keep the public API limited at the beginning. You can always come back to that and change it later, but at the beginning, keep it simple. The helper functions are probably going to change because you are making the implementation a bit of a hack at the beginning, right? And always remember that this is a contract. So beta interfaces might last forever, even though you don't want them to. So just be cautious and always keep that in mind. And then the next slide, please. After you have something working, how do you build and keep iterating? We'll release often. That's very important because you get more feedback from users more often. Use versioning. Specifically, we recommend semantic versioning because you can signal when you have breaking changes with major version bumps. Have a deprecation policy. It's hard to have one before your 1.0 version, but having something in place is useful. And be responsive to your users, but remember that you control the vision, not the users. And if you think something is worth building and is doable, you are the only one who can make that call. If that rankles people who have some sway, it is not the worst thing sometimes to let something sit on the backlog for a while. That's okay if that means that you can actually work on more important stuff in other places. Okay, and then I think I'll pass it off to Gus for the next couple sections.
Thanks, Ethan. All right, so we talked about how we kind of look at building tools and getting them up and running, but obviously there's more to good tools than just that, right? Can we go to the next slide? Right, so good tools are more than just their code. Your ultimate goal, both in building tools and maintaining tools, is reducing friction. And that goes just as much for how you enhance your code. If you reduce friction, your developers can more easily contribute and maintain your package. You get happier coders, and it makes your users more independent in how they learn how they learn about your package or your tool and how they use it. And it keeps them off your back, right? If they know how to use it, they don't need to bug you about every little detail. We go to the next slide. Right. So one of the big things that we always recommend is testing suite, unit testing, all that kind of thing. Automation through CI/CD, contribution guide with instructions how to use a suite so that your developers aren't just sitting there knowing that there's a testing suite, but they actually know how to use it to check their code. Can we go to the next slide? Yeah, right. What does this get you? Developers can easily check their work if they have a testing suite. It makes it easier for them to check what's working still and what they might have broken while they're trying to make updates. In general, it helps you identify bugs earlier. Obviously, testing is heavily going to help your developers, but it helps your users in that if you're identifying bugs earlier and your developers have a way to check that they're integrating in your code properly, they get more stable releases. And then your users are happier. They don't have to worry about bugs creeping in as often. They can work, your stable APIs generally be stable. It just helps a lot. Next slide. Right. Another big pillar that you'll see that we like to recommend a lot is documentation, right? From having a good README to having a change log to having a contributing guide, which we mentioned before, testing, but obviously that goes beyond just testing. And then having a website with guides on how to install, how to use, both at a high level and then at a more detailed level, an API guide. And then especially for when we're talking about creating tools within businesses, any business logic that's not necessarily obvious from your code or gives more context to why your code works the way it does, all of that should be documented. Okay, next slide. Right. Documentation as opposed to testing is going to be very helpful to your users because they can get started quickly and independently. And it gives them a good place to go first with the question. If they can go to your documentation, answer the majority of their questions, they don't bug you with it. They can get all their common questions answered, and then they can come to you when they have something deeper to ask about or something that isn't quite clear in documentation or a bug report. And on the development side, if there's a contribution guide and an API guide, new developers can learn how to get started with contributing, and also they can learn about your existing functionality. So not only do they see the source code, but they can understand what kind of mindset, what kind of decisions have already been made in your code, and then they can know better how their contribution should fit into your code. Next slide. And then finally, issue tracking, just basic things of having issues to submit bugs and enhancements and some kind of progress tracker. We used to use some kind of Kanban board. Next slide. Big thing, users have a direct line to your workflow. Similar to what Ethan said before, you're not beholden to your users when they request things or they submit anything, but it gives you a transparent line of communication about what they want, what you're doing, and what's being released. And also, if you're using something like GitHub, you get documentation of all those issues and their solutions for future reference. So that way, if people keep getting bugs or something else keeps coming up, you have that built in. Next slide. All right. So, we talked about tools, how to build, how to document, all that kind of things. But you need to maintain that quality, right? If you just build something and leave it, it's not going to mean anything. People are going to stop using it. They're going to find something else. Or they're going to build something themselves. So our two pillars of long-term quality are responsiveness and refactoring. You've got a user side and development side. Next slide. So when you're working with users, you got to remember that they are part of your maintenance process. It's not just you and your developers, it's the users. So you need to be responsive, literally respond to issues as they log them, just acknowledge that they've been received, ask for clarifying details so that way you can understand what's going on and explain as you're implementing solutions and have discussions about it, and then share progress updates as you're releasing things. So that way everyone understands what's happening and they can get their new code faster. Next slide. And we also mentioned refactoring, right? So we have the developer side of this. Next slide. Obviously, Clear Code helps everyone across every facet of development. You can see maintaining, implementing, onboarding, encouraging outside contributions, having clearer code helps across the board. Next slide, please. So the big thing is to be strategic. You don't want to be planning refactoring for every single cycle or whatever work session you're using, but you don't want to be just sporadically tacking on refactoring into PRs that have nothing to do with it. You want to strike a balance on trying to get that work done without taking up too much of your time because you have other stuff to do. Something that helps with that is if you put potential refactoring ideas on your backlog, then you have a quantifiable work item to come back to later. But however you want to do it, the big thing is do it in smaller units. Even if you're planning to refactor a big section of your package, do it in as small units as you can, do it in phases, all that kind of stuff. Next slide.
All right, so kind of high level takeaways. So really the purpose of our ecosystem has been around addressing issues when we've seen enterprise growth and really growth amongst a data science team. So as data science teams kind of grow significantly large, you tend to see stovepipe processes, code duplication, and code inconsistencies that happen across the company. And trying to resolve those, we have found to be extremely easier by doing it through foundational inner source packages. The inner source tools, inner source Python packages have really helped to kind of simplify and scale common data science tasks. And so what are some of the things that we have found as we've done this? Ethan and Gus kind of hit on them. Many different lessons learned around like how do we identify the problems that we want to work on? How do we do early development, which we really focus on kind of quick prototype, releasing very early versus very large monolithic projects with a long-term release date. And we really focus on the interface. That's something that we have found to be extremely important, where as we put out more of these inner source tools, the more common that we have the interface look across them, the easier it is for our data scientists to really kind of get up to speed and start working with them. And then some of the stuff that Gus talked about, maintenance, long-term support of our packages is extremely important. Putting the time and effort into refactoring and also having that relationship with the end users, we have found to be extremely important and beneficial in the success of these packages being adopted. So with that, Marcelo, we will just hand it over for any questions.
Sure, thank you very much. That's going to be fine. There are some questions by the participants, and Ethan was providing some support with them. Dilip was asking about what tools have you used to keep track of usage and metrics on your created packages?
Yeah, so I'll let Ethan talk to that one because he actually developed a fantastic logging tool that we use internally.
Thanks, Brad. Do you want to show the final slide? We have an appendix slide that mentions some of the internal packages we use, and that's actually mentioned. So I did respond in the chat, but just to mention that, basically what we found is, internal packages and tools often are of interest, like their usage amount is of interest to leadership and to the people developing them. And we basically went in with a goal of how simple can we make it to add usage metric collection. So we have a package which we call component logger, but all it does is expose a Python decorator. There's really almost nothing else users will ever see of the package, but adding the decorator to functions and classes in another internal tool will automatically do logging for them. And it handles complications like in what platform are you running? What database do you have access to write the logs to? So it writes to different databases in different spots. And then we have other tools to go back and read those logs. But it really is mainly for what you might call like telemetry. Like it's just sort of basic information about usage and when and who. And then I think there's another question. Oh, sorry, Brad.
No, I was just going to say, I think one of the important things to kind of call out about that is that was some initial logging that we did. And I think what has helped a lot is Ethan turned that process into a package. And so what that does is it makes it easy for other teams across the company that are building internal packages just to go ahead and throw that in as a dependency. And they pretty much automatically start logging themselves. So we made it very easy to do logging by turning that procedure into an internal package.
Yeah, and that's actually a bit of a callback to some of the other stuff we talked about during the session, where interface is so important compared to the implementation. Like originally, that was a total hack, but we did give people a really easy, simple interface to use. And by providing something like that, we got initial users, and then we were able to improve the underlying functionality over time. We didn't have to do it all from the very beginning. The other question, Gus, did you see that one? I think that would be a good one for you about philosophies or rules of thumb around deprecating libraries and functions.
Yeah. So obviously, we talked about throwing away tools. We don't want to deprecate libraries that often, but it comes up and we deprecate functions a lot more often. The big thing, like we talked about, is communication. So we do use our component logger to try to figure out how much people are using different aspects of our library. So that way we can kind of tell without even having to talk to users and trying to get their input, we can kind of see who's using what. Is something falling by the wayside, and we can kind of deprecate it, or if we're looking at breaking changes, who's using it and can we talk to them about new interfaces or just make sure that they're aware. But the key to doing all that is just communication. We try to, which even outside of deprecation, when we're just doing releases, if we're doing a major release with breaking changes, we send out a lot of advanced notice of, hey, this is how the API is going to change. Take a look, start pinning your packages so that way you can have a chance to test it before everything goes into production. We're going to minor releases where we just start adding new features, but we want people to know about it so that they're not caught off guard by having this new thing that could help them a lot. We'll send out emails ahead of time and as it's released. When you look at deprecating, it's the same kind of philosophy, just as much advanced notice as you can so that people can adjust their situation. And when we have time, we'll also, if we're deprecating for a specific reason, like to give a new package for that purpose, we'll start providing guides to show how to convert your code from the deprecated library to the new library, or if another team's developed a solution that's better use case, how to get to their library. It's really just being transparent about it.
All right, so there are some other questions from the participants. Tim Smith is asking, how do you support discovery of your tools among your client teams?
Yeah, I think we are in a good position there where we're kind of a team within the company known specifically for creating internal tools. So that's nice because we tend to have a lot of touch points with other teams and they do look at some of the documentation we produce. So they run into these, but also you can't underestimate how many people are going to just kind of tune out in the company and not pay attention to that kind of stuff. So really what you have to rely on is that a few users who really like the tool will tell their friends about it, basically is what it comes down to. You have to find like an evangelist user base, basically.
Thanks a lot. Another question by one participant is this. I'm developing an internal package, but I need to support Python 3.6 to 3.9. So I was trying Poetry to manage dependencies with backported stuff like database classes. Any recommendation on supporting a wide range of environments?
Does somebody else want to take that one?
Yeah, I mean, I think I don't think we have a great response to that. We do have a few different environments, like internally on our on-prem system. I think we're in like a 3.6, maybe a 3.7, and then we've got 3.8 in a cloud environment. The main thing I think that we do to get around that is we don't look to put in like the latest and greatest syntax adoptions within a release. We try to keep it simple, something that is across the different environments. We are starting now to get into the process of trying to do testing. Like when we do our unit tests, we will actually try to run them across different Python versions. That's something that we've actually just recently started talking about more and started doing. So it's something that is something we are working through. And I think that the main thing to think about is, one, how can you do testing to test across the different environments that you have? And then two, don't necessarily get wild and crazy on adopting like the latest and greatest syntax changes within a single environment. or version change.
Yeah, and one very small thing I would add to that, some good guidance is test on the lowest version of Python anyone's going to use, run your tests on that, and run your type checking on a newer version if you're going to use type checking, because you get a lot of conveniences in type checking in the newer versions of Python, and you could be more expressive and get better checks out of MyPy. But what matters is that the code imports and runs, not necessarily that the type checking works, but that the code imports and runs in the oldest version of Python. And that usually means you'll be fine all the way up to the newest, as long as that's like after Python 3, basically. So if you follow that advice, you're probably going to be fine. And those things pass, you're probably going to be fine 95% of the time.
All right. Thank you very much. There's another question from Raghu. He's asking, well, actually, it's a set of questions, but I will mention them in once. The first one is, did you face any roadblocks or communicating to management, right? Management regarding setting this up? Since setting this up is kind of non-billable work, management or executive team might not see the value in it. That's the question from Raghu.
Yeah, no, this is a good question. So I would say we did not necessarily get a lot of roadblocks initially from management. They realized that we had inconsistencies across many teams, and they really gave us some freedom in trying to address that. But I think what was important early on was we showed some quick wins. And we had a few different tools and packages that got adopted significantly and quickly across a lot of teams. And I think that made management understand just like the scale at which we can improve performance and code consistency across the company. And I think once we got those early quick wins, it was pretty simple to sell the need of new tools when they came up.
All right, thank you very much. Well, I think there are no more questions by the participants. Many of them are thanking you all of three very much. Dilip, I want to thank you for your time and your amazing presentation. I actually enjoyed having a session of a full team, a full data scientist team, right? Like working together in order to follow their job experiences as companies are following today, right? So I want to also thank all attendants who participated with their questions. It was such a wonderful experience.